How are you going to make it happen? We only need to replace OH with a hydrogen, but there's no direct way. If you're using the lithium aluminum hydride, as I said earlier, you will not get an aldehyde. It will go through the aldehyde, but aldehyde reduced further to the primary alcohol. So lithium aluminum hydride is not doing the job. What you need to do, you need to convert carboxylic acid into acid chloride. That can be done by the thionyl chloride or something called the oxalic chloride. That's another reagent that does the same job. This reactive chlorine can be replaced by the hydrogen, but it's gotta be weak hydrogen. Otherwise, you get an aldehyde reduced further to take an alcohol. So that's the weak. So that's the one that we talked about. Tri-hepatoxy aluminum hydride. That's weak enough not to touch this. So once that happens, stay there. So that makes a distinction. But as I said, this is not the only way. You can actually make this thing happen another way. Yeah, this is basically the process I was through. Sorry. This hydride of the tri-hepatoxy hydride makes an attack. This electron pairs go to oxygen. It makes a tetrahedral intermediates, but it will come back making a chloronyl by kicking these chlorines out because chlorines are good living groups. That way you get an aldehyde. But the point is, I want to make it is this alcohol you get by treating the lithium aluminum hydride, that can be oxidized to the aldehyde by using the PCC, PVC, chlorines, even swarm oxidation. A lot of things we discussed in chapter 11 can oxidize primary alcohol to the aldehyde. If you're using a formic acid to that, then you'll get the carboxylic acid back. So you want to choose wisely for your oxidant, right? But it can be done other way. So there's two different ways. One, you can go this way, one you can go the other way. So two different sets of reagents are very effective on both. They're both good answers. All right, the next one, you see the carboxylic acid becomes a ketone. So you have to replace this OH with an alkyl chain. So this is where you should remember that this cannot be done directly. We have to go through somewhere. And then I hope that you've got to remember that if it using a Grignard, for instance, with a carboxylic acid, you were hoping that maybe this could attack and keep the hydroxy groups out. That's not happening because a Grignard is a strong base, carboxylic acid is an acid. Acid-base reaction happens. Grignard basically pick up the proton, it's just be dead. So you cannot use a Grignard with carboxylic acid, unfortunately. So we need to convert the carboxylic acid to something else, like the acid chloride. So acid chloride appears a lot. Acid chloride has been used, we've been using that for a lot of different things. But it's kind of not acidic like this, and it can be replaceable because chloride is a living group. That's why we're using that. But acid chloride converted to this, Grignard doesn't do it. If you treat the Grignard to this, Grignard makes an attack, replace this, you get the ketone first, but the Grignard can react with the ketone. So if you go further, you get the tertiary alcohol like this. So Grignard is not the solution, even though it makes it, but it can take it further. You need to have a weaker alcohol, which is a diethyl cuprate. Diethyl cuprate replace the chlorine, makes a ketone, but this doesn't react any further. So that's when reaction stops here. But there's another way possible too. The things right now is there's always more than one answer possible. The other way, somebody forgot these things. What you can do, we can convert carboxylic acid into the aldehyde. We just talked about the previous slide what to do. You can do either reducing completely the primary alcohol and oxidize to the aldehyde, or you can also using those the acid chloride and then this tri-hepatoxy aluminum hydride, then you get an aldehyde. If you have an aldehyde, now you can use a Grignard. Grignard will attack, you get an alcohol. The secondary alcohol there, only thing that you need to do, oxidize alcohol to the ketone. That can be done easily by any oxidant, because in secondary alcohol, anything that you use, it will just oxidize. So there's always more than one answer. So if you just fail to go through the one we want you to do, still there might be other answers possible if you're clever.